No, please.
Very well. Well, welcome everybody to Melbourne Python. We have a QR code here for our Slack channel, but the QR code doesn't work at the moment. We've just found out, so we'll see if we can replace that during the break and get a proper one up there. But yeah, the Slack channel is the place to go to ask questions and so on. We meet here on the traditional lands of the Wurundjeri people, and we pay our respects to Indigenous elders. We have the fairly standard sort of code of conduct, basically don't be a jerk to anyone, or we get heavies from Judo Bank to escort you out. We're on the web in a couple of places. You can go to LinkedIn for the Melbourne Python user group. That's actually probably the best place to follow us. We're also on Mastodon, thanks so much. Tonight we've got two talks. The first one is Samko Yun from Neo4j, who is talking on the shape of suspicious behavior. There will be a break in the middle. If you want to announce any jobs that you're hiring for, then come up and talk to me before the break, and I'll give you a half minute or a minute when we get together again after the break. Second talk is Justin Warren on renegotiating the social contract for software. Then you can just continue talking, eating, and we will wrap up by 8 p.m. Our venue sponsor is Judo Bank. You noticed that already. Our other sponsors, Food and Drinker by AWS, and our other sponsor is Neo4j. We'll hear a little bit more about this evening. On our Slack channel, we've got channels for jobs, announcements. Oh, thank you. And volunteering. And there's a bundle of ways to get involved. That's including speaking, sponsoring, and volunteering. So to find out about any of those things, talk to me, or talk to Rinaldi, who will stand up now. And I'll just hand over to Michael for a minute from Judo.
Yeah, sure thing. Thanks everyone for coming. It's great to see another turnout here. If you don't know about Judo Bank is a bank playing in the SME sector, wanting to become Australia's most trusted bank. We've just launched a savings product recently, which has really great rates, so I suggest you have a look at our website if you haven't already. A little bit about this event here in the building. All the bathrooms are all the way past the elevators to your right, and that's the second door on your right. They are all gendered, so just so you're aware. If you have any problems with anything, doors locking, need any help with where bins are or anything like that, just let myself or any other volunteers know, and we can help you out. And if I can have your assistance in keeping this place clean, it'd be very much appreciated. Thank you.
Very well. Now, I'll hand over to Samko Yun. I'll just take a moment to get his laptop going.
Hello, everybody. Hi. So my name is Samko. Today I'm from Neo4j, as you can see. I'm here to talk about how we actually use the graph technology at some of the banks to identify some fraudulent patterns. And I'll briefly go over what was the success case, what technique that we have used, and also introduce briefly about Neo4j as a company and the technology as well. As you can see, I actually had a quite vibrant hair back then. I don't really dye my hair anymore. I used to do that at one point. So I started my career in LG from Korea, and now moved to Australia. I worked in IT consulting for quite some time. And then my last project was actually using Neo4j, and led up the opportunity to work in Neo4j, which has been quite great. Now, working in retail finance, public sector, we work with a lot of different industry customers in Neo4j, but I personally have more passion in FSI and in the finance area because it's a lot more fun to identify and find bad actors, which sounds like a detective, so that was cool. So there's a, link there. I will probably get back to that later. Today's agenda is I'm going to briefly go through the graph intro. Some of you might not be too familiar with the graph database technology, so I'll just briefly touch on the concept. And then some case studies that we've seen in the worldwide, globally, and also in Australia. For detecting fraud with graphs, there's some pattern implementation techniques that we have used in with our customers. And then we have, I'll show you what technique we have used in action. And lastly, because agentic AI is in everybody's mind, so I have to slip in that slide here or there, but it's not going to be too heavy on the agentic side. I do have more events coming up next week that I'll be doing a live demo on the agentic semantic layer. If you're interested, I also put the slide about the event at the end. Correct. All right, so how many of you have heard about Neo4j? Great, about half. So Neo4j is a graph database company, and we started 14, 15 years ago from Sweden, and we have the biggest presence in US and Europe. We have, if you click, I think this is kind of animated. Yeah, so we work with 20 out of 20 top banks from Fortune 100 company, and then automobile makers, pharmaceuticals, thank you, and then all the top telcos and aerospace, including NASA, and most of the companies you would have heard about from the Fortune 100 companies. And then worldwide, we have overall 2,100 customers. We have quite a bit of customer base in Australia as well. And then currently, we are working with a lot of the banks in Australia for some of the reasons you might already be aware of if you're from Judo Bank, that there is a SPF, a scam prevention framework that was being enforced by the Parliament that is coming to action next year early, which is basically asking all the companies to take more responsibility on detecting the fraud schemes. So that's why a lot of bank customers are reaching out to talk to implement the graph technology. All right, so into the graph intro. Thank you. So graph database is also just another database, but we are using a lot of different concepts than your technical concept, like tables, columns, and rows, right? We use nodes and edges, as you can imagine. So nodes would be, as you can see, the company, employee, CD. So any object entities will become your node, and edges will be how these entities are linked together. So if you have the company, then your company would have a CEO, and then a company would be located in a certain city. So all of that information is captured on the edge, and then because we are a property graph, meaning that even the relationship can have the property value inside of the edge itself. So has CEO, you have start date. Located, it might also be since or moved into a lot of different details you might want to capture that is going to help you identify some of the insights. If you can go back to, yes. So technical concept, I'll just quickly go. So nodes are the entity relationship, and then we also call the company, employee, CD, what you see here as a label. Single node can have multiple labels as well. So if you might have a customer node that also happen to be the employee. So you might have a customer of A and Z Bank, then you also happen to work for A and Z Bank, right? So they would have multiple labels. In your relational world, you would actually put that under a different table, like employee table, customer table, in this sense, because they're the same entity. We're entity-oriented, like for the nodes, so they can actually have multiple roles in them. Go into the next one. The benefit of graph database is quite simple. Graph database are all connected at the right time. So all the traversal from point to point is all the point-based. So meaning that there is no such thing as a table join or index lookup. If you think about, so we have all the information that I've just shown before, employee, company, CD. If you want that information, you would have to join 3 or 4, depending on how you structure it. You have to join a lot of tables, right? And then depending on the number of rows, if you're joining, self-joining, or anything beyond 5 tables, 10 tables, your query is getting exponentially expensive, as you can see. Whereas in graph, all the edges are written at the right time. So traversing from point to point is very linear. So even if you have to traverse from 20 tables, 100 tables, the traversal time is going to only linearly increase. You would have a very massive performance benefit if you're dealing with very complex databases. And graph database is flexible. It's NoSQL database, meaning that there is a schema list, but it also is ACID compliant. So you can use it for transaction as well as the analytical workload. You can change, one single node can have multiple different properties. It's not going to break it. You can, of course, enforce your schema using some constraints and index and some brief type. But overall, it's going to give you a lot more room to, for your database to grow along with your business. And it is insightful because there are a lot of inherent benefit of having your database as a graph form. Because if you think about it, all of our memories, all of our knowledge is in our brain is a neural network in concept. Like you literally chase your train of thought, like you think of one object. Oh yeah, this person is friends with that person, and that friend used to work in this company that I used to work. So there's a lot of like a connection that you need to, you're naturally thinking, while your database is all scattered as a table, which is like very haphazard manner, you have to stitch them together. So uncovering those insights can be quite expensive, but because you have all the pre-connected data points, all the main question that we can answer, what's important, what's unusual, what comes next, all this question can be answered simply by traversing from node to node, or you can leverage some graph theorems, such as path traversal or centrality. A lot of these graph theorems are naturally available to you by having your data set as a graph. And then I'll touch on some case studies, especially about financial crime and then some company structure. I think the most popular one is probably Panama Papers. How many of you actually heard about the Panama Papers? Great, it's been in the news for a while now, right? So just the gist, so there have been quite a bit of, if you click again, yeah, so it's basically the whole tax evasion scandal that came about like, 6-7 years ago, I think. So what happened is like this Panamanian company, law firm, have actually leaked some crucial information about some like tax information to journalists in Germany. And they decided to, okay, there's so many different companies and millionaires involved in there and trying they all regarding the tax evasion, swindling. And how do we actually find the crucial information out of all the documents that are leaked, right? If they're so we had started with the 3 journalists, but for them to go through 2.6 terabytes of data would have taken them decades to uncover whatever's in there, right? It would be, by the time it would be too late. What they've done is they actually started using the graph to extract the right entities and relationship from those Panama leaked data and put that in the graph. And by using some visualization, graph visualization, all the journalists, all the analysts, without having to write any cipher query, any kind of technical things, they were able to traverse from person to person, company to company, uncover a lot of hidden insights within a very short period of time. We're able to recover $1.36 billion overall worldwide. From Australia alone, we were able to recover $138 million from this Panama paper scandal. So that was one of the biggest use case that we have actually seen that's seen the true value of the graph. And then I will speak to some local customer that we have actually done also in New Zealand. We are also working with a lot of different local banks and banks in Europe as well. So there are different types of fraud. I'm not going to speak too much about the type of fraud, but first party fraud, obviously, the person involved is the person who's trying to commit the fraud. You're deliberately lying to the banks to take the loan out, or trying to get any kind of account to abuse it, right? So in this case, we work with the loan application. So you potentially the fraudster, the bad actor, would fill out their information wrongfully, and then trying to take the money out, with no intention of paying back, right? There are so many things that we wanted to uncover, but the key thing we wanted to do with this customer is, so there is many syndicates, not just 1 or 2 actors. Typically what happens is a fraudster, I work in a group, they kind of share a lot of information, they're like a group movement. How do we see the connection whenever there's a new application coming through? How do we know if they're associated with a syndicate, right? So that's why we wanted to use the graph to actually see if we can actually uncover them. So using a couple of the graph theorems and technology that we've used, I'm going to cover a little bit later on the technique side, we were able to increase the links identified to the largest syndicate by 150%. And our false positive rate has gone from 2.2 to 1 to 0.3 to 1, meaning that every one real fraud that we uncover, only 0.3% would be like false positive. And it was like in kind of measurable term, it was like 16 times, I think, more accurate. The overall entity resolution, alert volume, all of that operational effort, because like that's the big thing. Like it doesn't matter if we're like increasing the volume and identifying, alerting everything. At the end of the day, your operation team is only managed like limited. So it is also important for us to make sure we provide the right quality of the alerts. To the next one, and then there's the second party fraud, where you're not always directly the fraudster, but you're actually either you're either like handing over your account knowingly, or like maybe your account's being stolen by somebody else, and then that account being used for fraud activity, like a money laundering or something. So without going too much detail, so we were also able to uncover like increase the detection rate by 10 to 20 times, which was quite massive. And then our false positive reduction rate was also 75 to 95%, which is 20 times in precision. We were using a lot of different information, but in this case, we used how many like account ownership, and then how many people have like a share device, or share email address, or share residential address, and then all of that connection from the graph, we were able to traverse really fast, like in the massive scale. That's why we were able to like double the operational efficiency and productivity. Lastly, but not least, the third-party fraud. If you go to, thank you. And then stolen car fraud. It's our biggest fear. Always somebody just like snatch our card, or like our RFID to scan your credit card and like use it somewhere else. Same situation, and this is the digital wallet situation. So we actually had a lot of information about how many users have like different digital wallets, how many users are having multiple devices. So all of that like suspicious pattern, we were able to like put that in a graph and actually increase the proactive detection by 650%, and then more than 100 plus syndicates were identified, because by using the device and by using the shared device and person identifiable information, we were able to see, oh, these two people seemingly completely irrelevant, but they are actually connected via either sharing the account, or sharing the device, or sharing the some type of information. So these are the cases that we actually worked, and then all those numbers are like real numbers that I personally like got involved and then see all that in action. I remember at one of the showcase, our customers were like kind of blown out of their mind, and then immediately they were like, we're actually using the real data as well, and then they were like, oh, okay. While we are demonstrating, we literally identified the one person that seems like engaged with a lot of the fraudulent activity, or genuine customer. They were like, okay, let's stop this, we need to investigate. So it was actually like pretty cool to see that in action too. Okay, so detecting fraud with graph. Why is that important? Because financial crime has never been this high before. It's kind of 5%, this is like a global data, so it's not necessarily Australia alone, but overall, a lot of the business, like over 5% of the revenue was lost to the fraud alone. And then 30% customers switch provider after the fraudulent incidents. If you have with, it's not just the banks, like it's also with the telecom, right? If something happens with Optus, we switch to Telstra, but then Telstra happens and then switch back. And that's what everybody does. And then over $40 billion estimated loss due to FSI, like financial sector, in 2027 alone, due to Gen AI. Because we're not the only one using AI. Fraudulent bad actors, they also have access to all this like cool tech. So it's going to be a lot more challenging to identify and detect them in advance. The problem with that is like, you have to deal with those like people with the traditional databases where you have this crazy ERD diagram with the data tables correlated to each other. Like, where do we start? How do we like join all this table? Like, how do we actually uncover this pattern? It's going to be a nightmare to do that with the traditional tool, because like, if anything, the hackers and fraudsters, they're actually on the pioneering technology. They're going to use whatever that's available to them and trying to like swindle you. We have to do the same. We have to use the technology back to them, which is where the graph comes in. So I briefly mentioned about the SPF, the Scam Prevention Framework. So this is the Australia related information. So $2.7 billion estimated financial losses in 2023 alone, and then last time I checked, 2024, steadily increasing in lost money. And that's why the Parliament of Australia is enforcing all the banks, digital media and telecom companies to take more responsibility, identify instead of just blaming the customer who unknowingly are transferring money. But like banks has to do their job to identify, right? That's why they're like on fire now. Because like in the next one, what the scam prevention asks you is a principle-based obligation. Do your due diligence to prevent, detect, and disrupt and report all the fraud, all the scams that's happening around you. Failing to meet this criteria is going to cost you quite a lot of money penalty. Not only that, reputational hazard. So that's why a lot of people realize, okay, the traditional tool, all the available tool that we have is not going to cut it. We need to up our game, and that's why they were starting talking to Neo4j graph database company. One by one, I'll just briefly mention how graph technology can actually help with each of these obligations. First, with the network for scam prevention. Your traditional tool would have the database for cars, online banking, mobile app, know your customer, all the data siloed on its own. You would have to pull the data from there and then make the connection. Even if you're using AI, they have to spend a lot of tokens to connection stitching together. Whereas in Neo4j, in graph database, all the assuming that you have your knowledge graph in your all of that in one graph, you can actually traverse from your card to the customer to the account related to all the fraud cases that are raised against. So within single core, you can actually traverse one-to-one quite quickly, because also I mentioned there's no index lookup. Performance-wise, it's going to be a lot faster to identify, detect in real time to disrupt, which was actually a point that I was going to cover later, but next one. And detection. So this is the example ERD diagram, like what the bank's customers' transaction account information would look like. But what I've seen in action, what my colleagues in Europe and America, what they've seen in action is like most of the time the fraud alert detection is very superficial. They put a flag on one mobile number or one device or email, and whatever transaction or request coming through directly related to that information gets detected. Anything beyond that gets ignored or it gets lost, which is baffling to me because I thought we were doing a lot better than when you uncover a lot of the companies. I'm not talking about one bank or one company because I've seen a lot of different systems, how they're doing. It's quite superficial. They're able to jump between the loops between the relationship. Whereas we can, if you have an account that eventually are connected to the fraudulent email, what we do is based on the degree of separation, we can actually assign certain risk score. Based on the threshold, we can alert them, even if they're so far away, eventually they're related. And then because we're identifying at the point in time that are most crucial to the whole fraudulent activity, that's why it's so meaningful. We're not just trying to catch the foot soldier. We're actually trying to find the mastermind. And what helps with that is using the graph technology. So these are two of the graph theorem that is available to you from Neo4j. One of them is the community detection. So as you can see, so these are also from one of our POC that actually from real data. This is representation of what customer have what PII. So your email, mobile number, and the device, right? So most of the cases, one person only have certain number of mobile device. Even if you're sharing a mobile device or email, as a family, that cluster is not going to be bigger than a certain number. So when you look at that cluster, that is very unusual pattern. That this about 20 people were sharing 7 different devices, 10 different email addresses, and 5 residential addresses. All of that leading to them overall working together as a group. That's how we're identifying using the community detection algorithm. You just have to run that algorithm. It'll give you the score. It'll give you the size of the community, and then you can assign the score based on what rules that you're setting. And then between its centrality is something that I really personally like. Centrality is explaining basically how many edges do you have as a node, right? But if you have the multiple nodes, directly engaged with a lot of suspicious nodes, that is gonna dead giveaway. But the problem is, most of the mastermind, they're not gonna do transaction on their own. They're going to be connected to people who have the most connection, right? So you're controlling this game. Between centrality exactly does that. It's going to identify the node that might not be have the most edges, but it's going to be connected to those who have the most edges. So that's going to be the score that we're giving using the betweenness centrality, and that's how you're actually disrupting, not at the end like foot soldier, who are controlling the whole game. And so these are the type of graph algorithm you can use: the pathfinding, centrality, community detection, machine learning, embedding similarity, to name a few. We have the most number of graph algorithm in the industry from the graph technology, 65 plus, depending on how you count it. And then the way it works, it's too detailed, I'll just leave that be. And then if you want to test it out, it's all available for you to try out. It's open source, and then you can try it out like a cloud version as well. It's called Aura, Neo4j Aura, that you can sign up without anything, and then immediately test it out. Next one. So how am I doing the time? Oh, okay, so we'll just rush through a little bit because this is like too much. So reporting, we have some visualization tool for you to like traverse between the nodes without writing any codes. Called Bloom browser, all available on Aura, so feel free to test it out. And then let's just jump into the fun part where we are talking about the graph action. Yeah, thank you. How do we do it? This is one of the POC example like reference data book that I pulled out. It's not really specific to any bank, so it's kind of pretty generic. So you have your customer account transaction, and then your PII, phone number, email, address, how they're connected to jurisdiction, country, and then if any of the customer have been alerted on certain scenario. So this is the typical model. Yeah, thank you. And then how we do is like it doesn't differ too much by case to case. Overall, we are always like following the same formula. So first step is to use, as I've mentioned, we're trying to run the impact analysis. You typically start with certain flag, so you already know, oh, these numbers or these devices, like this email is like suspicious. So anybody who's linked to that information, we need to flag it. Like so, there's depending on how directly they're related. First degree, second degree, third degree. You can assign different level, and then you can identify how far away are they related to, and that's what we're doing. And then surprisingly, and not surprisingly, because you can create as many email addresses as possible, but device is quite pricey. And then most of the time, fraudsters don't really have a lot of iPhones. They have a lot of cheaper smartphones to actually utilize. So depending on the device, you might actually have like 10, 20 customers related to that single device. That's really easy to actually identify and then expand your impact analysis. And the second step, based on that, we are adding on to more things. We're not just traversing from one point to the other, we're actually trying to identify suspicious pattern. When I talk about the suspicious pattern, the money movement, like money laundering, tends to do in circular movement or a certain way. So there is a weird way, if your money is going all in circle and eventually coming back to you, like that's not really normal. So those are the patterns that we can actually identify without having to write hundreds of lines of SQL query. And then once we have that, we combine those two output and then come up with a risk scoring, depending on how many degrees separation you are from the suspicious device or PII, depending on how many suspicious transaction pattern that you currently have. That will give you the overall fraud score. That whatever action that you're taking from then on, you will be alerted based on that. So that's kind of like a simple thing. We always like go in circle, and then out of that scoring, you identify and then confirm some fraudster. Then that would be feeding into the next impact analysis. So so that goes in circle. This is like two patterns that I've actually seen in real life. And circular money movement, you can see Gianna transfer a certain amount of money, Ivan, and then they all actually coming back. There are a couple of rules that you would put in place. For example, like at any given time, 80% of the money always goes to the next person, because these people would take the commission out of it. But if that pattern persists like more than once, and then that's just like a very suspicious pattern. We've seen a lot of this also for the tax evasion from one bank to the other, then another, like back to the one bank, right? Bank A, B, A, B, A, B, that's another pattern that we actually identify. There are a few patterns that we can do, and then in, then out. You might transfer, like you might be the one who distribute all the money, and then you might be the collective aggregator. So there's a typical pattern that, like within a short amount of time, it's unusual amount of money that one person's are giving or receiving. So those are the patterns that you can identify. What you can do with the, if you go to the next one. So this is the SQL query, for example, that you would have to write for circular money movement. That is only identifying the ring size of 3, 4, 5. That's the SQL query that you have to write. And then if you want to identify the money circular movement of 10 people involved in, good luck. You're not gonna get there anywhere. And what you can do with the Cypher is, this is the real query that would be represented in Cypher. Cypher is the query language that we use in Neo4j, and then it is also basis of the GPO, which is the new ISO standard language for the graph technology, and it's implemented across a lot of different graph vendors, graph database companies. So you can see, and it is quite easy to understand. So you're identifying the pattern. We're not even giving the anchor point. You don't need to know the person to look for. Like what graph does is like once you know the pattern, you can just describe it in the syntax. It'll give you the answer. So what happens is like we are identifying the ring size between 3 and 16, and you can go as high as like your RAM allows. So what happens here is like account sent transaction, and if the transaction is like repeated in that pattern more than what 15 times. And then there are the condition. Like it has to be like sequential. Obviously, I mean you're not identifying the haphazard like time sequence, right? It has to be in sequence, like going coming back. And a certain amount of money has to come back. So that's just the rules that you can change. Conditional loop pattern detection. That's all that it takes, and you can just change the number without having to add huge block of SQL. That's how you write the SQL. And then if you go to the next one. And then risk score, as I mentioned, once you have the impact analysis and then you have written the pattern analysis, all of that would feeding into your risk scale. First scale is a known fraudster exposure, how far away you are associated with the known bad actors or known bad flag identifier. And then you also add the secondary scale, which is obviously the how does your money move? Is there, as soon as you take the application like loan, does the money immediately go to a certain vendor? Like, you know, there is a certain like rule set, a certain pattern. Like, does it like happen in one rolling window and 1 week window? So all of that would like count to create your own risk score. That'll fit into having highly accurate risk alert. Next one, thank you. And this is it's a very wordy slide, but it was something that I actually personally, is my favorite. So out of all the community detection, I personally like community detection the most, because what it does is actually it gives you very tight modular community, and it's not going to, if any weak connection between the nodes, it's going to ignore. If they're very tightly coupled community, then it will track it and it give you the score. And then what also is great with the Lightning community is that you can actually track it over time. 1 week you have the one syndicate, and then next week, oh, it's syndicate, like there are 3 people joined. And then the week after, there are like 5 people joined. Oh, we actually have the emerging syndicate. And then we also have like, started with the one syndicate, over time, and then in the next few months, that syndicate somehow like, you know, modularity changed, and then they broke into 2 different syndicates. They still work together, but they have like more compact operation going into 2 different syndicates. So this is the pattern that you can actually use. We didn't even have to use a lot of complex link. We literally just used what mobile device, mobile number and what device did they share? Because, like I said, device is quite expensive. They're not going to have like 1,000 devices to use. So it's quite easy to use that. Based on that, you can traverse out to the transaction. Then it'll give you access L link as well. And then to wrap it up nicely, we have agentic AI slides. So we have quite a few new features coming up in Neo4j. One of them is, like just for this case, if you go to this one, thank you. We have a official MCP server for Neo4j. So once you have the graph, and you can just like set up the MCP server, your agent will be able to use that tools and skills to like write the query, and then immediately extract out information, and then even runs graph algorithm for you in this case. So it'll give you, whatever, basically, like you have your own expert, then you can actually immediately test it out. It's very easy. If you have to clone, then just plug it in, put the config, done and done. If you go to the next, one of the things that I've used the MCP to demonstrate for customers, for SPF, one of the regulation is that you have to create, not just SPF, like for other scan as well, you have to write a suspicious matter report. They all have different name in different countries. That's the name that we use in Australia. So it takes analysts weeks to compile the information, uncover their source, and write the report. When I gave the whole fraud graph to the agent, and then I gave, okay, so we have the SMR report syntax and template as well. According to the template and using our knowledge and using the graph theorem, identify some suspicious person and write a report about it. And it just spit out that report in a matter of seconds, right? Obviously, it needs a bit refinement, but it's really hugely speeding up the whole process of writing this report using the simple like MCP server with the AI. And so, if you want to learn more about the AI side of it, like these two upcoming events in Melbourne is exactly what that is. So we have AWS Startup Day, which is next Monday. I'm talking in 3 days. I'm going to be speaking at the AWS Startup Day. I think it's the open kind of event. If you have time, swing by. My speech is 2:45. I'll be running live demo on this enterprise semantic layer using the agentic AI. And then we have Graph Talk coming up 20th of August that we are also talking about. We have customers speaking about how they're using the Neo4j for their agentic AI solution. And also we're releasing some exciting news about what new features and what new partnership coming through from the Neo4j. That's it. Thank you so much.
Very well. I'll just ask, was there a question or two that anyone had?
Yes.
Is there, I don't know if you've worked with many US clients, is there a unique challenge in Australia without instant bank transfers and that being so quick and every bank having to kind of implement that compared to other places where it might be slower or checks?
Yeah, thank you. Surprisingly, it's not that different. I think the only problem with Australian banks are they're still quite green in terms of like experimenting with the graph technology. So that's probably the only challenge, and that we have to make sure we give them enough assurance that we've done this in the US banks, and yeah, that's pretty much. And then a whole like SPF bill is actually trickling through like the entire world. Like we have the same initiative in London 2 years ago and in Singapore last year. Now it came down to Australia. We're kind of the late runner, but that gives us better platform because we've already done this, right? So.
More from the architectural point of view of graph databases, is there any way to avoid tangles or messy logic in the actual construction of the databases, or when going back to redesign it, is there any way to recover that data non-destructively and put into the new model?
That's a very good question. That's the same challenge that I always have with the customers. Everybody's coming from the relational background. They don't have to explain to me. I came from the relational background, so I understand where you're going, right? And then what I always suggest is like try not to create a graph data model like a one-to-one. Like you have your entity table, and then it immediately becomes a node, and then whatever join table becomes a relationship. I mean, that's easy to start with, but when you start asking the question to the graph, and then when you're writing the cipher, the performance could vastly change, and then exactly you might end up with an entanglement that you didn't intend to use. So my recommendation is always like you come up with 5 to 10 competency questions, like what you're trying to solve, like what question you're asking the graph, right? And then what people do is before data modeling is like you're whiteboarding first, right? You're not writing the tables and columns first. Like you're writing the problem and then try to identify whiteboarding, how do they relate to each other? That becomes a model itself. That's why it's so great. Like you need to kind of unteach yourself what you've learned as a data engineer. That like, oh, you have to think in ERD diagram. Like you have to separate the join table, and you have to try to normalize. So always start with the competence question, and then you expand it out. Like I said, graph is quite flexible, and then the remodeling is quite easy. Just like your node can become edges, your edges become properties. It all comes down to how efficiently can you write the cipher for that query. Shorter the better. Yeah, so that's We have a graph academy actually does touch on how to model the graph. So you can just Google Graph Academy, and then all the courses are free. And if you finish, I didn't really put that slide here, but if you finish it, then you get a free T-shirt from Neo4j, and you know.
All right, we'll wrap up there. Just one last question. What's the name of the Python package?
It's we have a lot of different Python packages for graph. We have like Neo4j Graph Rack.
What's best for beginners?
That's for beginners. Just a simple Python package. Actually, I had the list of Python library, but not on the slide. Sorry. Let me just. Because I spoke last year, yeah, and then I did actually put that slide up. This one I didn't.
Oh, while that's happening, if anyone wants to announce any roles that they're hiring for, talk to me during the break. We'll take a 15-minute break and come back at 8:05 or so.
Good evening. Thank you for sticking around this late on a Thursday to listen to someone that you don't know talk about social contracts. How many people here, is this your first meetup here? How many people are here for the first time? Ooh, lots of you. Excellent. Welcome. Thank you for coming along. Please enjoy Python. I hope you find the community welcoming. We'd love to have you here, and hopefully you come back. For those of you who are not new, also welcome. It's great to have you here, and for the people to keep coming back, we want that. It is a pleasure to be able to be here tonight and to talk to you about something which is close to my heart. It's about free software, not just free and open source software, but free software particularly, and I use that word advisedly. The reason for that will become obvious very soon. So we can grab the next slide. That's me. This is my email address if you want to get in touch with me later on. Feel free, or just come and have a chat. And I am findable online. You can seek me out. That's the face to look for in various forums. And this is the company. I'm the principal consultant. It's mine. I own it, but it's tiny, so I get to pick whatever title I like. On with the show. So, there is a lot to cover, and I am not going to be able to do any of it very much justice. I'm going to try to pack a lot of different concepts into a very short period of time. I'm going to try to keep this to probably about 20 minutes or so there's a bit of time for questions. We'll see how we go. I have given some of these ideas a bit of an airing before, but there's some new themes that I'm also introducing in this. This is building on a concept I've been working on for probably 2 or 3 years, but really about 20. Right, so this is the summary. I think that the biggest mistake that free software made probably 30 years ago was that we mistook the creation of individual software artifacts by individuals as being more important than the maintenance of software ecosystems by humans. And I think we should change that. I think the stuff on the left is more important. And this is why. Everything is broken. Who's been patching everything constantly? Yeah. Who has to deal with compliance things where you actually have hard SLAs to do it? Yeah, all my day. It is driving me mad. Happily, Python is probably the least of my issues. The Python ecosystem is not too bad, although it will let us not get complacent because I think that people have discovered that they can find bugs in Python too. So, yeah. It's not safe anymore. All the computers are broken. What happened? And it turns out most of the software that runs on these computers is weirdly free and open source because we won. It worked. It's not proprietary software, although, well, Windows sort of is, but Windows is full of open source software as well. And it's broken all the time, and it's easy to find out why it's broken because it's open source. In some ways, it's actually harder to do that for proprietary things now because you can't just read it. Also, don't plug anything in, ever, to anything. Why does my fridge have Wi-Fi? Why do I need to patch my television? I have to patch my dishwasher. Why do we connect everything to the internet? Partly it's useful. It is handy when daylight savings happens because I don't have to go and change the clock on my oven, which has Wi-Fi, because reasons. we have a bencho, we call it a bench oven, what do they call air fryer. It has Wi-Fi. Everything has Wi-Fi. Why did we connect everything to the internet? Because this is how the money works. I did have a variation of this slide on a previous talk where this bit of the curve was actually quite a bit higher because consumers were getting a bit of a better deal out of this. I think it's changed and it's not this great anymore. Most of the money is going up there. We're going to maintain this. Yeah. And here's another view of why that is that way. This is what I think is the cost-benefit allocation of your interaction with this ecosystem. So if you are a hobbyist or a consumer, consumers had a great deal for a long time. It was really, really good. All of this software that was amazing quality, could do all kinds of things, and it was free. That is a superb deal. I love it. I have run free software on that laptop for a very, very long time. But I think it's changing, as you can see from these arrows. So the previous version that just had the dots, this version I think it's actually getting as a worse deal now, because as a hobbyist and a contributor, if you want to stay being a hobbyist and a contributor, it's much harder now. Partly because everything is connected to the internet and everything is broken all the time. So now it's becoming a chore. It's not as much fun. For me, it's not as much fun. Who else has been involved in this, and do you find it as fun as it used to be? Yeah, come on, that's a bit of a drag. So, why? The purpose of a system is what it does. That is a paraphrase of a quote by a guy named Stafford Beer from the 50s, I think, 60s. He wrote a book called The Brain of the Firm. He was one of the people involved in the creation of an academic topic called cybernetics, which has sort of come back into fashion. It went out of fashion for a long, long time. There's a particular system I recommend you read up on called CyberSyn that was operated in Chile in the 60s. Interesting story. There is a good podcast about it. But this is what we did, particularly in companies who were using open source as part of their marketing plan, was we said, hey, go use the software for free. It's awesome. You don't have to give anything back ever. And everyone went, okay. And then about 3 or 4 years ago, everyone, because money wasn't free anymore, they went, not like that. But that was the deal. So we got the system that we designed. If we want to have a different outcome from this system, we will need to make a different system. The purpose of a system is what it does, not what we want it to do. If we want it to do something different, we have to change that system. Because in some ways, we have treated software as if it's disposable. And I think that's actually become a lot more common recently with the advent of code generation. There's always been this idea that wouldn't it be great if there was no code? I don't have to code things, I can point and click on a few things, and I don't have to hire programmers who ask me pesky questions about what I want. Just build the thing that I have in my head. It's obvious. Why can't you just give it to me? Explaining what you want to other people turns out is kind of a drag. So just go back. So now we have these systems where you can tell it, it's like, I want the thing, and it will generate something thing-shaped. And if I only need one of them, and I only need it to last for a very small amount of time, and it's cheap enough, disposable software is pretty appealing. I write one-off scripts that I don't plan to maintain. I've got one task, and when it's done, I'm finished. Awesome. And anyone else do that? Yeah. And it happens a lot in sysadmin. That's quite good. It's quite useful. But there's a big difference between disposable software and software that you need to stick around. The software that runs production, which is where I spend most of my day, operating things and looking after production, that stuff has to work all the time and it has to keep working. We don't throw it away at the end of the day. Sometimes with the cloud we sort of do, and there was how many people have heard of the pets versus cattle analogy? Yeah? It turns out that the cattle are also sort of pets. The cattle have names, some of them actually need special treatment and handling, and not everything in AWS is perfectly fungible. And it doesn't quite do the thing you need the other service with a different name. Yeah. It turns out that it's not all disposable. We do actually need some of it to live on day to day, and it has to be maintained, which is why this book is awesome. My favourite book. I read this at the beginning of the year. It was finally published towards the end of last year, I think. It's by a couple of French academics. This is the English translation. It is in French. It is a bit academic and quite French, but I mean that as a compliment. It has some lovely stories in it. There's a couple of anecdotes that I won't spoil it for you. Please do read the book, it's great. Get it from the library if you can, otherwise it is worth money, I swear. There are a couple of stories in there which are both excellent and also extremely French. Highly recommended. This book, sorry, come back one. This book explains why maintenance is important, because maintenance is about the care of things. It's not caring about things, although that is important. It's important to care about them, but it's about caring for them. And that's the sort of ethos that I've taken into my daily work and how I approach software now. And I invite you to do the same thing. The book also opened my eyes to different ways of thinking about what caring for things means, what maintenance means. There are different kinds of maintenance. It's not just about keeping it the way it is today. Sometimes maintenance means restoring it to a previous state and looking after it in that state. But which one? How do we determine what that is? Figuring that out, it turns out, next, involves politics. Now, for a lot of people, politics is a dirty word. I was going to put this at the beginning of the talk and said, warning, there is politics. The subtitle of the book is The Ethics and Politics of Maintenance. Politics is important because politics is the term we use to describe how humans organise themselves and figure out how well we organise the work and what we value. How do we make decisions about that collectively? If you're on your own, you don't really need politics, although some of us manage to practice politics in our own head. And sometimes it's fun. But as soon as you have more than one person, you have two, now you have to argue about who is stacking the dishwasher correctly. We're all wrong, turns out. Everybody is wrong about it. No one reads the manual. Except if you're German and created it. I think they actually just have some sort of inbuilt ability to pack dishwashers efficiently. At least that's what the manual tells me. So practicing politics is a thing that is going to happen. You will either be involved in it, or it will involve itself with you. It will happen to you rather than you happening to it. I recommend having at least some agency in that process, because that's how we can influence the kind of world that we are going to live in the future. Because technological systems that we are involved in and we are responsible for building, creating and maintaining are social. They involve people. It's not just tech. This is a great book. It's a collection of academic essays called The Social Construction of Technological Systems. The abbreviation called SCOTS is around in the academic literature. I recommend this as a gateway into that. And it really drives home how much politics and the values that we have as humans influences the way in which systems are created and deployed and maintained. So after that slight diversion, this is one of my sayings I like to say all the time. The first 80% of writing software is putting bugs in, and the second 80% of the project is taking them out again. How many people have figured out what that sums to? It doesn't include any overheads for project management or any of those other things. And anyone responsible for the budgets on any of these projects? Yeah, did the budget fit the project? Yeah. Often there is a lot of project left at the end of the money. It's a hard business, but there is hope. And it's already been done for us here by this wonderful woman, Nobel Prize winner, Elinor Ostrom. Tremendous work. Her work was studying a thing called common pool resources. Actually, it was around economics and how that influenced ecosystems. But her particular specialty was a thing called common pool resources. And I think that's really important for us to understand in free and open source software. And I'm pretty sure the next slide explains why. Yes, hooray, I got it right. So this is a pretty classic matrix thing. I'm a consultant, so I have to use at least one matrix in every talk. That's what they teach you in business school, I think, after that money is more important than people, I think. It's something around spreadsheets. I forget, it was a long time ago. Matrix, have to do one. Preferably 2 by 2, other matrices are available. I'm not going to go through the details of the axes because it's academic and confusing. What's important is the names that are in the big boxes. The lines are arbitrary, things are a bit fuzzy in the middle. It doesn't necessarily suddenly you go halfway across the matrix graph and go, oh, I'm in a new country now. It doesn't work that way in real life. But these are pretty good categories for describing the ways that they work. I'm not going to go into them in huge detail in this talk. I have done in previous ones, so do find those on the internet. There's a bit more of an explanation. Or feel free to read up on your own time. But these are the four basic kinds. Where is software? In clues? Anyone want to shout out? I'm not going to put you on the spot. No? Okay. One guess?
I was going to say, it's a trick question. Is it even in the box?
Or close. You're almost close. Right, there we go. Next slide, please. It's all of them. But importantly, they're different kinds of software, and I think this is particularly in the top side. Top half, I guess? Half, yes. The top half is the most important one. I mean, we all have a lot of experience with proprietary and SaaS software every day. We almost can't avoid it now. SaaS sort of took over a lot. ELIZA is an interesting one. And the next slide, I'll put both of these together so we can refer to them without having to flip back and forward. The reason I think it's important and interesting is because that's sort of where the focus of free and open source software was right at the beginning and pretty much all the way through. Because the focus was on an artifact, was on software that had been built and already exists. Because the marginal cost of distribution is extremely low. You can make copies of it, basically. If you don't have copyright, or if you say, yeah, sure, make a copy, it's totally fine, you don't owe me any money, it's really cheap to do. Cheap, fast, the internet, which we connected everything to. Why? Because it's really, really easy to make copies of software across the internet. So I don't need to go and get a floppy disk or a proprietary weird bit of hardware and plug it into my dishwasher to patch it and upgrade it if I want to change its functionality. I can just do it over the air. That's why we did it. ELIZA and software like that is old and static. It doesn't really change. It doesn't involve any maintenance because it already exists and we don't need it to change anymore. It's reference software. It's interesting and useful, but it's a public good because it's unchanging and it's basically an idea. Whereas free and open source software, and I would argue to a large degree proprietary and SaaS software as well, they all need maintenance. And that's the bit that we haven't done very well. And free and open source software, I say, sits up in this common pool resources category, which is very useful because it means that we don't have to invent how we change this social contract. We don't have to invent it from first principles. We can go and look it up in a book, which is really handy. Yep, next one. Because, thanks to Eleanor Ostrom, she discovered, described these 8 different design principles, I think they're called. Yes, it's from this paper called Reformulating the Commons from the year 2000. And it outlines these 8 ideas. I'm not going to go through all of them in detail. I'm going to pick out a couple. I don't have slides for the specific ones because I'm interested in talking about them with you individually afterwards, if you like. Particularly important, I think, are ones that we're seeing emerge right now, which is clearly defined boundaries. Who is allowed to contribute to a project? And under what circumstances? How are their contributions welcomed or not? Are you allowed to have AI-assisted code come into the project? And under what conditions? Is it completely forbidden? Is it allowed a little bit? Is it, well, only if you attest that you actually understand all of the code and everything that's been written, or, hey, free for all, knock yourselves out? Who gets to decide? How do we decide? Politics. Collective choice arrangements. It's open source. We are sort of a collective. Do we choose to operate together as a group, making group decisions, or do we have benevolent dictators for life who get to make a single call and say, well, I think it should be X, and what I say goes because I am king? We are democratizing software, apparently, by creating more kings. I'm not sure how that works, but it's interesting. Rights to organise. Are we allowed to organise ourselves into a collective that can say no? How do we resolve conflict? Something which I think all of us in open source, particularly in the tech industry, but particularly in open source, have been very, very bad at. We did not design conflict resolution mechanisms in from the beginning. We kind of made it up as we went, and we had a crisis and went, oh God, how do I deal with this now? Instead of thinking, humans, when have they ever been in conflict? So there's a lot here that we can learn from. We don't have to make it up ourselves. Because we can say no. We can choose not to do the things that led to the system becoming the way that it is. Maybe we can say, actually, bugs in software sucks. Why is it that a product that I spent lots of money on, that was sold to me by a $1 trillion global company based in the United States, if I buy a chair from them and it is faulty and broken, I get to, they will take it back and give me my money back and fix it, or give me a replacement. If it's software, apparently no. If it's broken and they built it, and I am legally prohibited from going in and changing any of the code, which I don't get, and I'm not allowed to reverse engineer it either, why is it that that is okay? Why is that the deal? And it's not the deal very soon. In the EU, they've changed the rules, so the Cybersecurity, Cybersecurity Act, I think it just is, will change that. We're starting to get product liability for software. It's going to be really interesting. I don't think that anyone in the world is ready for that yet. We'll see how it actually plays out in practice. But the other thing we can do, again, we haven't been very good at that certainly in the software industry, but in free and open source software parts of the world. We haven't been great at solidarity either. Doing things together as a group and saying collectively, no. Or yes. Or that's not how we will do things here. When we make those choices, we stick together and enforce them as a group. You can do things differently over there in that project. That's fine. We don't do that here. And we are not going to do that here. And if you want to do that thing, you can go over there with a different project. You're not welcome to do that here. We could do that a lot. We could do it a lot more. That's okay. We can have boundaries and we can enforce them. But stable systems resist change. That's what stable means. So we should expect that the existing system that we've built, that we've constructed, it's going to fight back. If we try to change it, and anyone who has done any kind of change process at any kind of organisation will know this. Anyone done change? Yeah. How'd that go? Yeah. Fun, huh? Humans hate change when it is someone else's idea. If it's my idea, it's awesome, obviously. Why aren't all of you agreeing with me that the future will be great if you do things my way? Politics, influencing, getting people to change their minds. Turns out that's quite hard because it's nothing to do with the technology, it's everything to do with the humans. I don't have that slide, I have a different t-shirt, I should show that one. Humans ruining everything since forever. Because the purpose of a system is what it does. And I really hope that you get that into your head. I love this and I use it all the time. It's become a bit of a mantra of mine, a little bit one track perhaps. There is some nuance in it, but largely what it means is, if you're not happy with the way the system is working, you have to change the system. You can't say, oh, well, I didn't intend for it to be that way. That's nice, cool, you didn't intend for it to work out that way. I didn't intend for you to step on my foot and cut off my toe. But it happened. What's important is what we do about it. Do we change the system or do we lament it and go, well, who could possibly have known? Who could have predicted that this obviously predictable thing that has happened 90 times before would happen again? Maybe we need to actually think about that ahead of time and think, well, it hasn't gone well previously. What are we going to do differently this time to stop it happening? How can we design that into the system? How can we take that into account from the very beginning, rather than being surprised when it turns out, memory safety is a good thing. It's quite handy. Sometimes booleans aren't. Sometimes strings are weird. Names, anyone have to deal with names? Dates, time zones. The best. Anytime you touch any of those, if you haven't, please step away, it's awful. Just use the library. there are dragons. And lots of really small dragons with bigger dragons inside them, somehow. Because I firmly believe, or I've come to this belief through long and bitter struggle, that the maintenance of ecosystems by humans is more important than the creation of software artifacts by individuals. And I think that that is playing out right now. We are seeing the outcome of getting this wrong all those years ago. We're seeing that play out in real time. But we can make different choices. We can make different systems. We can design them differently. We can operate them differently. We can maintain them differently. And we can choose to do this so that we end up with a better world, one that we want to live in. That's the book. That's the QR code. Please go get it. There is another one, I think. Did I get? Yep, that one. If you would like one of these handy stickers to go and put on all of your devices at work, in reports, I highly recommend. If you go to that QR code, I have a website. You can put in whatever number you like. In fact, it doesn't even have to be numbers. Play around with it. There are Easter eggs. Have fun. Enjoy. Also, I have some stickers of that if you want to come and grab it. I don't know if I've got enough for everybody. We'll see how we go. But if you would like one, I have a few of these that you can stick on your laptop and annoy people with. And I think that's about it. Questions? Questions?
Yeah, I'll bring this up. Speaking of time zones, if anyone hasn't seen Tom Scott's video on time zones in YouTube, I strongly suggest you watch it. It is hilarious.
This is not at all where I thought this talk was going to go, and I'm really glad I was wrong about that because this was fascinating. Thank you. You, in your discussion about free and open source software versus, what do you call them, public goods, or ELIZA, I think was the...
yeah, common pool resources compared to public good. Yeah.
Sorry, I'm terrible with remembering names.
That's okay.
The sort of the thing to me about free and open source software is the software is the software. You have the source. If you want to make a change to it and the project itself doesn't agree that it's a good idea, you don't necessarily have to go with them. You can build it yourself and you can run it in your environment. So there's a distinction there between the software as the thing that's running in production and the project that maintains the software. And I was wondering if you could maybe spend a little more time untangling that distinction, because you did a great job, and I think there's a little more, if you could put a little more color into that.
I can put a bit of colour in it, but yeah, that's bigger dragons inside smaller dragons. Yeah, that in itself, it is a big topic. So I don't want to dismiss your question. I'll give it a quick go. Unless, did you have something to add?
I have a question.
Second question. Okay, well, I'll come to that as well. So I can't give it the justice that the question deserves. I'll give you a little bit of the flavour. So the idea of like a hard fork and a soft fork, I don't have a good citation off the top of my head. There is some interesting research on how many forks have succeeded, like what is a successful fork. Like HashiCorp got a hard fork of Terraform that became OpenTofu. There's one of Vault as well called OpenBow. There have been others where people go, yes, we hate you, the Judean People's Front are evil, we are now the People's Front of Judea. It's an old leftist joke for those who know. The momentum is really hard to sustain because it turns out it's not about software, as you point out, it's the ecosystem around it, and taking a group and being splitters, splitting the group off and going off, taking your bat and ball and going home, and trying to do it all yourselves, it turns out that's quite difficult. And the bigger the project with the more links into other parts of the ecosystem, the harder that is. Because it's about network effects, and it's even things as simple as that, well, we just build the software. How many people have actually built software from source code? Like, have you built the operating system from source code like we used to do from, it's like, wait, yeah. Have you done it in the last year? Yeah, it's quite hard now, because things are very complicated, and there's a lot of infrastructure and stuff that goes with that. Like even bigger, I mean, Linus talked about it recently, and he's difficult. This is why we shouldn't have dictators. Just fork it, sure. And you and what army? Like, how are you going to maintain just the device drivers for how many products? and build it on what? Like how do you actually construct? It's quite difficult. Small projects you can, and if you only have to make a small change and then you are never worried about changing it because there's never going to be security bugs, it has no exposure to other systems, and the system you're running it on will also never change. Debian now doesn't run and ship for x32, so you can only run it on. Now, if you take a modern Debian, you can't run on an x32-bit chip, you have to run on 64-bit chips. So if you take old Debian, it's not compatible. Do you even have a VAX or a mainframe Z-series? Like, how many people have a Commodore 64 in your house? I don't, but I know someone who does. I do have a 5 3/4-inch floppy drive though. I'm not sure that I have the ISA card that I need to plug it in. So, short, and I don't mean to be dismissive, but it's harder than people think.
So when it comes to the maintenance of existing free open source software, do you have any opinions on what sort of vetting process it should be, especially with the influx of large language model users just submitting fixes for whatever things there is? I know you mentioned that you've got opinions of licensable vaults, but you recently said there's going to be AI usage deal with it.
Well, I'm a rich middle-aged white guy, so of course I have opinions. Apparently they're the only ones that anyone wants to listen to. Which is to say, who cares? They're my opinions. That doesn't matter. It's your project. The group who are running, the people who are doing the work are the ones who get to figure that out. There is one thing that I think was pointed out by my friend and colleague Christopher in a talk he gave, which I have cited previously, which was another mistake I think we made, was to equate the idea that pointing out a bug, that doesn't have the same or equal value to actually fixing the bug. Noticing a problem isn't useless. Like, it does have some value, and people should point out that actually this doesn't work very well. It's not very accessible, for example. I find this difficult to use, or it doesn't serve this particular underserved community well. Fine. But hey, there's a bug. Yeah, cool. We got 7 billion of them this week. And what? How? There is only so many hours in the day. The project of the people who are doing the work, well, they should get to figure out what happens with their project. And I don't want to tell them what to do. It's not my project. I might have opinions, and if it was a democracy, depending on how you organise your democracy, maybe I get a vote, but I only get one. I should only get one. Otherwise, it's a different. Otherwise, it's not democracy. It's theocracy, or I don't know. What is it when money votes? I can't remember what the name of that one is.
Sorry, you got me trying to figure out the word. You nerds, not me.
Excellent. You'll be thinking about that at 2 a.m.
Oh, I will. When you talk about maintenance versus new creation, it's a problem that you, I think, even mentioned exists both inside the open source world as well as, heck, I suspect a number of us, we've seen it exist merely inside our enterprises on stuff that never even leaves our offices. How do we culturally start shifting the celebration of creators away from the quiet maintainers? I know that a lot of enterprises and extremely big search engines that start with G have a rich history of celebrating and rewarding people who create brand new things, and then letting my beloved completely anonymous RSS reader die.
Yes.
For instance.
You may recall a previous talk mere moments ago where I mentioned about organisational change. It's hard. It's really hard. Like cultural change in particular is really, really difficult. There are ways to do systemic change. What you get more of what you reward. So change your incentive structure. So if you are giving rewards to people who create new things, turns out they will create more new things. Salespeople are highly motivated by money. Turns out other people are also highly motivated by money. Not always, but there's other things that people value as well. But if you get rewarded for doing one thing and you get punished for doing another, all but the craziest weirdos, and sometimes that's me, will do the thing they get rewarded to. It's like, this hurts and is difficult and hard, so most people will stop doing it. Sometimes not, because we have other motivations. You have to change the incentive structures, you have to change the system. There's no good answer, but I think the clearest help I can give in that circumstance is there's a consultant saying that the cucumber gets pickled more than the brine gets cucumbered. So when you go into the system will win. Change from within by one individual, almost impossible. You have to change the system in order to change the impact that it has on the people within it. And that takes coordination and solidarity with a group of people. You can't do it by yourself. Unless you're the CEO, and even then, many companies manage to spit out their CEO with no change, including one with a big G at the front. I don't know her personally, but I do know the reaction that happened.
Very well. I think that wraps us up for tonight. We'll be closing in about 15 minutes, so how about the pizza and drinks and everything? And I'll put the QR code for our Slack channel back up, Slack server back up on the screen.
One more quick thing, if I may. Jack will annoy me if I forget. He was supposed to give me a discount code. He hasn't yet. Chase me up, find me online, or probably won't have it tonight. But if you find me at some point, if you're interested in going to PyCon in Brisbane next month, there are some discount codes floating around. I will have one in a bit. Do come. I'm giving a talk. It's a keynote. It's just on the Saturday. I think I have to go on book flights and stuff. Do come. Pretty cool.
Very well.